Analytics 101. It's normal to pretend to understand modern art, Bitcoin, and New Yorker cartoons. However, it is not cool to feign an understanding of analytics, because analytics is serious business. This video will help you understand some of the key terms associated with analytics. First, let's look at data, which is defined as raw, unorganized outputs that includes both useful and irrelevant information, which must be processed to become meaningful and useful information. Nowadays, most data is captured and organized digitally. This is called digital data. Fisheries and Oceans Canada and the Canadian Coast Guard create huge volumes of digital data every day. From financial data stored in enterprise systems, to sensor data on vessels, to scientific field data, and all those emails, photos, videos, Excel spreadsheets, we are awash in a sea of digital data. On top of all this, we access large amounts of data from other government departments, open government, non-government organizations, academia, ports, industry supplier partnerships, as well as the Internet of Things. The Internet of Things, IoT, is essentially a giant network of 25 billion connected things or devices. It contains all sorts of data generated by individuals, companies, and governments around the world. The term we use to describe all this data together is big data. All data can be typically categorized as structured or unstructured. Structured data is entered in an organized fashion, usually by columns and rows, and a defined relationship between it and the other data points using interfaces, such as Excel spreadsheets and enterprise systems. DFO and Coast Guard data is often structured by systems like Abacus, Maximo, iFleet, or PeopleSoft. Unstructured data, as you might expect, is the opposite of structured data. It is data that doesn't reside in a traditional row-column database. It includes things like images, audio files, video files, social media posts, and emails. Unstructured data is the new frontier for analytics, as all sorts of artificial intelligence algorithms can now be used to make sense of it. Now, let's talk about the different terms used to describe how we use the data through analytics. Analytics may be a complex term to understand or describe to a neighbor. World-renowned expert on analytics and business innovation, Thomas Davenport, explained the concept in an easy way. Analytics first started in the era of business intelligence, where the focus on implementing enterprise warehouses to capture information and use software to query and report it. He describes this as Analytics 1.0. Since the term business intelligence, or BI, was born during that time, we will describe BI as the activity of describing what happened in the past, also known as descriptive analytics, or determining the source of issues that happened in the past, diagnostic analytics. Modern tools now allow organizations to perform automated BI with ease and using beautiful interactive reports. When big data became a thing, analytics evolved to include data outside of an organization's own internal systems. Davenport describes this as Analytics 2.0. Analytics 3.0 arrived with the advent of inexpensive, powerful computing and increased accessibility to artificial intelligence, or AI, and machine learning. AI is a system that autonomously makes assumptions, tests and learns patterns from data to perform advanced business analytics using powerful computers. With these technologies, analytics can now be used to predict the future with a certain level of certainty, known as predictive analytics, or even offer solutions for issues found by traditional BI, known as prescriptive analytics. To keep things simple, we will use the term business analytics, BA, to describe this latest evolution. An example of BA for Coast Guard would be to use data to predict where a distressed mariner is located during a search and rescue mission, or predict the likelihood of a marine oil spill before it happens. Let's recap. BI looks at understanding and explaining the past, while BA looks to predict or offer solutions for the future. While using analytics and AI is possible for some things at Coast Guard or DFO today, the need to improve the quality of our data cannot be overlooked. It would be ineffective and possibly even dangerous to use bad data to feed a prediction model. For example, this could put the life of the mariner we described earlier at risk if the prediction model uses bad data to predict his location. To commit to analytics and AI, we also need to commit to things like data governance, which helps define and ensure proper controls for data, and business digitalization, which is the exercise of replacing manual and paper-based processes with automated processes to generate and store data in a digital format to improve its quality for use in analytics. Hopefully these terms now make more sense to you, and it will be easier for all of us to discuss the important topics of analytics at the Coast Guard and DFO.